Hi everyone, I'm Shubham Jhanwar. I'm a master teacher at Vedantu. We are discussing JEE Advanced 2018, Paper-1, Mathematics, and the question for this video is this. For a non-zero complex number z, let argument of z denote the principal argument with argument of z being between minus pi open to pi closed. Then which of the following statement or statements is or are false? So here, it's important for us to note that there are four options and we have to mark the options or the statements which are false. So here the first three statements are very simple and the fourth one is a better one. So let's first quickly solve the first three. A part says argument of minus 1 minus iota equal to pi by 4 where iota is under root minus 1. So clearly this is a false statement. Why? Because it will be minus 3 pi by 4. As you can easily understand that minus 1 minus iota is like minus 1 being the real part and minus 1 being the imaginary part. So the point in argument plane, it becomes minus 1 comma minus 1. And since I am taking argument's principal value, which is supposed to be between minus pi open to pi closed, so this essentially becomes 3 pi by 4, that to minus times. This angle is 3 pi by 4, but since this is in clockwise direction, it's minus 3 pi by 4, the argument. Coming for the third one first, for any two non-zero complex numbers z1 and z2, argument of z1 by z2 minus argument of z1 plus argument of z2 is an integer multiple of 2 pi. That's true. Yeah, so A is false, so this is my answer. And when it comes to C, argument of z1 by z2 is essentially argument of z1 minus argument of z2 plus 2k pi, where k belongs to integer, or you may say integral multiple of 2 pi. So clearly you can see argument of z1 by z2 minus argument of z1 plus argument of z2 minus argument of z1 plus argument of z2, it's integral multiple of 2 pi. So this is false. Sorry, this is true. So we don't have to mark it as an answer. So C is not my answer. Now coming to B, the function f with domain all real values and codomain minus pi open to pi closed, defined by f of t equal to argument of minus 1 plus iota t for all t belong to real, is continuous at all points, as t belongs to real, where iota is under root minus 1. This is clearly false. Why? Because it will become discontinuous when t becomes 0, or I should say when t is around 0, this will become discontinuous, or you may say it becomes discontinuous at t equal to 0. So let's check it out. Minus 1 plus iota t. So here clearly, when t is less than 0, the argument will essentially be what? The argument will essentially be between minus pi by 2 to minus pi, or you may say minus pi to minus pi by 2 when t is negative, because it will be in third quadrant. Minus 1 comma t point would be in third quadrant of argument plane. If t is positive, then minus 1 comma iota t, the point representing it would be in the second quadrant, because real part being negative and imaginary part being positive. So the argument will be between pi by 2 to pi. Yeah. Now what about when t is 0? When t is 0, the argument of minus 1 is essentially pi. So now you can clearly see as t increases from minus infinity and moves towards 0, the argument decreases from minus pi by 2 to minus pi. And suddenly at t equal to 0, the value becomes pi. And as t increases further, being positive, the argument reduces and moves from pi to pi by 2. So clearly at t equal to 0, there is discontinuity. And as it says, it is continuous for all, t belonging to real. That's false. And hence, this is also part of my answer. Now coming to the D part. First of all, it should have been phrased better. In the sense, in generic way, we can say locus of the point z lies on some curve. However, a locus lying on some curve is not a very appropriate phrase. It should have been like points z satisfying this condition, or you may say point z for argument of this. lies on some curve. That is a better phrase, yeah. Or when it comes to locus, it should have been mentioned this way, that locus of the point Z satisfying this condition is contained in a straight line, or contained on a straight line, sort of. So nonetheless, let's keep rolling and let's figure out whether it is true or false. So here for this, let's consider this diagram. Here points Z, Z1, Z2, Z3 lie on a circle, where Z1, Z2, Z3 are supposed to be some fixed points. Z is supposed to be a variable point. Now again, these are points representing respective complex numbers Z, Z1, Z2, Z3. We mean this. Now, what about argument of Z minus Z1 divided by Z minus Z3? First of all, Z minus Z1 will essentially be this vector, Z minus Z1. Z minus Z3 would essentially be this vector. So argument of Z minus Z1 divided by Z minus Z3 is essentially argument of Z minus Z1 minus argument of Z minus Z3. So this essentially becomes this, and since this is in anti-clockwise direction, this is some positive angle, so to speak. Yeah. So so let me say this angle to be, say, theta, and hence this angle also becomes theta. Now what about argument of Z2 minus Z3 divided by Z2 minus Z1? Z2 minus Z3 would be essentially this vector. I mean, it will be this vector, but I'm just concerned about the direction. So it will be having this direction. And Z2 minus Z1 would be a vector having this direction. So argument of Z2 minus Z3 divided by Z2 minus Z1 is essentially argument of Z2 minus Z3 minus argument of Z2 minus Z1. So here again, this essentially is in anti-clockwise direction. So let's say this is angle phi, and so would this angle also become phi. Now if you see carefully, since it is a cyclic quadrilateral, yeah, there is a circle circumscribing it, so you can say theta plus phi is indeed pi. So that essentially means argument of Z minus Z1 by Z minus Z3 plus argument of Z2 minus Z3 by Z2 minus Z1 is pi. So that means Z, the locus, can be contained on a circle also and not necessarily a straight line. So that means D is not necessarily true. That means it is false. Yeah. Now just to further comment upon D option, can locus of point Z, so to speak, lie on a straight line? Yes, it can. It is when Z, Z1, Z2, Z3 are collinear. So let me just show you. Say I have a straight line on which says Z1, Z2, Z3 are like this. That means Z1, Z2, Z3 are collinear. Yeah. Now for this to happen, that argument of Z minus Z1 by Z minus Z3 plus argument of Z2 minus Z3 by Z2 minus Z1 to be equal to pi, Z should lie on the line on which Z1, Z2, Z3 lie. Now to be more specific, if I should consider argument of, so let me just write this, since I have been referring it again and again, I'm basically saying Z minus Z1, Z minus Z3 plus argument of Z2 minus Z3 divided by Z2 minus Z1. And what we have been given is, this is supposed to be pi. Yeah. So the comment has been that it's not necessary that Z lies on a straight line, but it can also lie on a circle. Yeah. If Z1, Z2, Z3 are non-collinear. But what if Z1, Z2, Z3 are collinear? So here argument of Z2 minus Z3 divided by Z2 minus Z1. So Z2 lies in between Z1 and Z3. Just, a case we are considering. Yeah. So here clearly this will be negative. This will be negative. Yeah, because Z2 lies in between Z1 and Z3. So for So you may say, and this would be negative real value, yeah, because clearly you can see that z2 minus z3, the vector representing it, is collinear with z2 minus z1 wala vector, yeah. So here, and of course they are unlike vectors, yeah, they are not like vectors. So that means the ratio of them would be some negative real value. And argument of a negative real value is you may say, in fact, you may say pi. So my bad, z2 minus z3 divided by z2 minus z1 is a negative real value. Argument of z2 minus z3 divided by z2 minus z1 hence would be pi. So that means argument of z minus z1 divided by z minus z3 should be 0 as such. Yeah, because my argument is supposed to be between minus pi open to pi closed. So clearly here z should lie on either side of z1 or z3. That means either z should be on left of z1 or on right of z3. That means either z should lie here, of course not including z3 sort of, because then the argument of z minus z3 would not be defined. Why? Because argument of 0 is not defined. Or z should lie on left of z1. Now this you can easily understand that if z is on right of z3 and z is supposed to be some real, my bad, z minus z3, let's say represents a vector, then z minus z1 is a collinear vector. Yeah, so that means their ratio would be some positive number and argument of some positive real number is essentially 0. So this is just a further explanation to this option D, that locus of point Z can be part of a straight line but not necessarily part of a straight line. It depends whether Z1, Z2, Z3 are collinear as in this case or not as in this case. So hence D is not always true. So that means we will take this as false. Yeah, because it's not necessarily that, locus is not necessarily to be a straight line. So A, B, D are my false statements, hence my answers. Thanks for listening. Stay tuned for the next question.